Hello, everyone. Welcome back. I'm Scott Ananian. I am the tech lead for Parsoid on the content transform team at the Wikimedia Foundation. My first logged in edit to Wikipedia was back in 2005, and I've been employed by the foundation for 11 years now. I define most of the low-level APIs that Ad liked so much for the table of contents. Although the folks in the web team did the nice templating stuff, the skin side. I'm thrilled to be part of the MediaWiki Users and Developers Conference today to talk about something that we haven't often talked about outside the Wikimedia projects, which is how we maintain content on our wikis as our software continues to evolve. So let me start by introducing my team and our work, broadly speaking, Parsoid and wikitext. We're going to train our joint LLMs on some specific vocabulary first, which is probably stuff we all know. Wikitext is the markup language used to write articles on MediaWiki wikis. What the browser actually displays is HTML, and the parser is the component that turns one to the other. Parsoid is the new parser we've been working on since 2012. And the original impetus for Parsoid's creation was Visual Editor, which was a new way at the time to edit MediaWiki articles. So visually, the text on the left is wikitext. It's what I think we'll hear tomorrow scares people. And the stuff on the right is the HTML that the browser actually used. Somewhat interesting here, this is Parsoid's output, and we have some things like meta tags here, which are invisible to the reader, but do correspond to semantic information, which was in the original wikitext. And that semantic information can be used by gadgets on the page, which are client-side, as well as editors like Visual Editor or various tools. So in general, this is the main feature of Parsoid compared to the old parser, is it preserves all the information from the original wikitext, including the template boundaries, comments, other invisible metadata, and markup. And this enables round-trip conversion from wikitext to HTML and then back to wikitext, which allows us to edit wikitext with an HTML editor, which is what Visual Editor is. But in the process, we've also, by necessity, had to grapple with the wild and woolly world of what wikitext actually is, documenting and standardizing it, and often cleaning up its rough edges. Although we began Parsoid for use by editors, its use has grown over time. So it now powers a content translation tool, Flow, the Wikimedia Enterprise product, discussion tools, Kiwix, our mobile apps. But the HTML, which desktop users see, has still been generated by the old legacy parser. Obviously, maintaining multiple parsers in parallel isn't sustainable in the long run, and we began the parser unification project to gradually replace all uses of the old legacy parser with Parsoid. And in 2024, this year, we finally began to actually roll out Parsoid for read views to generate the HTML that you visit on an ordinary article page when you read it. And again, just visually, this is Visual Editor, right? This version of it has always been generated by Parsoid since the beginning of Visual Editor. And it does have some metadata involved when you're doing a Visual Editor, like the translation markers. This is article view. In this particular case, because I grabbed it from my laptop, this is Parsoid's rendering of the article view. But when we talk about read views, this is sort of what we're looking at. When you're not editing the page, you're just reading the page. Historically, that's been still the legacy parser because that's the thing which is indexed by Google. It's got a lot of high impact if you screw that up, right? So the first kind of announcement in this context for third-party wikis is that the parser migration extension, which we're using to start rolling out Parsoid for reviews, is not WMF only. You can install it on your own third-party wiki. You can opt in your third-party wiki to using Parsoid, either for all users or for admins first to figure out whether the extensions that you're using on your local sites are going to be compatible with Parsoid. Most cases, we expect this to be super boring because Parsoid is literally pixel for pixel identical to the legacy parser in almost every case. But, of course, the places where that's not true are the interesting ones. And that's the point of opting in. So right now, the parser migration extension sort of looks like this. You get a user preference. You can configure on a wiki basis whether or not all pages default to using Parsoid or whether they default to using the legacy parser. But then each individual user can also opt in to always using Parsoid, opt out to never use Parsoid. Perhaps you've got an important business case that this person does that's not compatible. And then on an individual page basis, each individual page you can also opt in and opt out at this point. It's mostly set up for doing this transition and finding these problems. Okay, so now we're 10 slides into the talk, and you know about wikitext, you know about parsing, and this new thing called parsoid. But the title of my talk promised something about square brackets, so what's up with that? So let me tell you an ancient tale. A tale so old, browsers were still using HTML4, and no two browsers displayed HTML in exactly the same way. Especially if there was broken HTML on the page, and of course, browsers also different about what broken HTML was. There was this upstart called XHTML, which said that the right thing to do if anyone, if you forgot to close a tag, was just to stop and display an error message, right? And that was like, there are people who seriously believed in that belief system. And in those dark days, MediaWiki introduced an HTML4 based library called Tidy to MediaWiki, and Tidy's job was to make sure that the output of MediaWiki was always perfect, pristine HTML that would satisfy even those XHTML purists. And whenever it was given broken HTML, it fixed it. Of course, there wasn't any standard for how it should fix it, so it just sort of made up its own rules about. The important thing was that it was always correct at the end. But gradually, those fix-ups became part of wikitext. And making a long story short, after a walk in the wilderness, eventually the same problem was solved in a different way by the WG working group with the HTML5 standard. It finally said exactly how you should fix up various forms of broken wikitext and what that should look like. But of course, now that didn't match what Wikipedia did, what MediaWiki did with, when an editor forgot a tab or put something that wasn't permitted inside the table or whatnot. Oh yeah, sorry, I skipped. So 2004, Tidy, 2015, it started to become obvious that there was this mismatch. Editors started complaining things displayed differently when they wrote HTML inside wikitext or when they did certain things on Wiki. And in 2016, we did some initial tests. We found out that about 93% of the pages were unaffected by the shift to HTML4 or 5. But that's still 7% of all pages on all WMF wikis is a huge number of pages which needed to be fixed up somehow. And this process took 3 years, more or less. It was not a short fix. So how did we manage it? Basically, 3 things: tools, a lot of community engagement, and a phased deployment. We're going to mostly talk about tools in this talk, but I'm going to pause here to underline that getting community involved and on board was a really important part, and that an orderly process for rolling out changes instead of breaking everything all at once is also key. The result was that we could finally unblock new innovation in wikitext, right? Starting with the template styles extension, which was the first thing. At the time, Visual Editor was also using HTML5 syntax from the start, so there were differences that were starting to appear between how Visual Editor showed something and how it actually rendered on Wiki. And this was the first step towards the parser unification project that I started out by discussing. So the thing to underline is the goal of content migration fundamentally is to enable new features, right? If you need to make an omelet, you have to break some eggs kind of thing. In order to actually do new things on Wiki, you have to take into account that sometimes those new things are going to be incompatible with the old things and have a process in place for fixing that. So square brackets. So here's a list of things which use square bracket syntax in wikitext. WikiLinks. 2001, UseMod Wiki developer and Wikimedia participant Clifford Adams invented the square bracket syntax for WikiLinks to replace the older camel case style links, which Ward invented in '95. So this was a feature of wikitext which was not as old as Ward's wiki, but older than MediaWiki itself. Interwiki links were actually added in 2002 as with the first version of modern MediaWiki, and this is slightly older than Brook, but other than that, now we're back to the rest of the room. Now we get to category links. Unlike the others, those are invisible on the page, and their placement in the wiki text doesn't matter, although people have very specific opinions on where they should be. And as a result, they're quite problematic in modern MediaWiki. A lot of tools have to tread carefully around them, and there are special tools and gadgets like Hotcat, which allow you to edit the categories as if they weren't part of the wiki text, more or less. And the modern consensus is roughly that they shouldn't be in the wiki text at all, but instead maintained as separate metadata somehow, which is indeed how editors like Visual Editor present them. Enter language links. Like category links are invisible on the page. They point to equivalent versions of the same article in other wiki projects, typically in other language. They have been replaced, but for all practical purposes in modern Wikimedia, by equivalent information source from Wikibase. And now we get to our third invisible square bracket link, the semantic MediaWiki property annotation. So perhaps you're seeing a pattern. Past this point, all the invisible things are all things that we really, at this point, sort of wish didn't work that way. There are alternatives in semantic MediaWiki, which use this parser function syntax, which is the standard way to do extension points in MediaWiki, modern MediaWiki. So we could spend a lot of time here debating like whether or not we should go back and make this work and add a new extension point, which currently doesn't exist in Parsoid, just for semantic MediaWiki, which is more or less the last holdout of this weird internal parser for links extension point. But in order to sort of, we can have that debate later over at the bar or something. We're going to go with this for now. Take this as our use case. Oh yeah, right there, right on the second talk of the day. Okay. But so assuming we want to get there, and we can disagree about where there is, but there is some place with more modern wikitext syntax. It might not be square bracket syntax we're talking about, maybe something else. How do we get there from here? And again, this is only our example. We're going to use it as a running example because it's convenient for a lot of ways. But maybe you have a different problem, right? Maybe there's some cargo migration that you need to do, or some other tool that's specific to you where you need to migrate content. So we're going to talk about tools that are available that can help, and broadly, like what process we could figure out together to make this a more routine task. Oh, good. I'm on my time here. So talking about tools. So we're going to start with the original content migration tool. I didn't go do the research to figure out exactly when the tracking categories were introduced, but they're super simple. So from semantic MediaWiki, there's this internal parser for links hook, which is on my ad list.
Your request from the right that you face this way.
That I face this way when I'm talking. Where's the actual microphone? Is it there? Okay. My notes are there. That's convenient, but the slides are back there. So it's right. So internal parser for links in semantic MediaWiki. Adding a tracking category is one line of code, right? When you add that tracking category, it shows up on a special page which lists those tracking categories with localized information about them. And from that point, it's just a normal MediaWiki category. Your editors and admins can click on the category, they can see all the pages in it, methodically try to fix them up. A big limitation in the traditional tracking categories is that often the problematic markup is generated by a template, and you'll see 1,000 pages added to the category because they all use one template, which just happens to have something bad in it. And this can be really hard to see from this sort of view. So in part to address this, there were other reasons as well, but in part the linter extension was created. Originally part of the HTML5 migration project that I discussed earlier. It's not quite as simple to create a new lint. Let's see, while still facing in this direction. This is a lint which was recently added to try to add night mode support. So a lot of MediaWiki templates set colors, they don't set background colors, and so when you can make the page night mode, suddenly you can't read the stuff because the colors are wrong, right? So the web team is working on trying to use the linter to help editors update their templates to be night mode compatible. So most of this is their logic. They're looking for a style node that has a background color but no color, or maybe it's the other way around. Yeah, background color, no color. The actual lint is the last 3 lines or so, which find an enclosing template name and generate what we call DSR, which is the DOM source range, where on the page that particular problematic thing is, and records it. The linter extension displays the links by category on a special page, somewhat similar to the tracking categories page. But at the bottom, you can see that we actually track the template which generated the lint as well. And when you click on edit, you're brought to the editor with the problematic source range highlighted and ready for you to edit. Again, so I'm abbreviating a lot, but community participation is really vital. Like I'm showing the bare mechanics of how this works, but the volunteers have created innumerable help pages and FAQs and guides to what this lint category means and how typical fix-ups look and whatnot, which is kind of really important to making this work past the technical level. Okay, but at this point, past this point, there are dragons. So we generally don't use automated edits on Wikimedia wikis. We have thousands of volunteers, and they really want to look at everything to make sure that the correction which is being done is correct. For this audience, it's not clear that all of your wikis have thousands of volunteers willing to do this, and the idea that an admin is going to have to deal with a category that's got 1,000 pages in it and manually fix them up is pretty untenable. So these next tools are really what I came here to talk about, is what tools can we give an admin of a third-party wiki to do automated fix-ups in a way which might not be appropriate for Wikimedia wikis, but will help us make these sorts of things routine and easy for an admin when they upgrade to a new MediaWiki version. Yeah, if you're wondering, right there is apparently where the dragons are. It's the Isle of Dragons. So I'm quickly going to run through 5 different tools that do automated or semi-automated edits to content, which could be used for mass content migration on wikis which don't have large linting or a cleanup community. On the wiki browser, 2 frameworks, PyWikibot and MWBot, and 2 extensions, Max Edit, Regex, and Replace Text. For context, as we start out, a key challenge is going to be how we reliably recognize the old markup that we want to update. So here's a story from an old versions of Dungeons and Dragons, which was published. It had numerous instances of something, the word "the wizard," in the core rulebook. Does anyone know that story and know what went wrong? Whoa. Anyone guess? Without spending too much time. Turns out there's another word for magic user is a mage. And so we did a search and replace just before publication, changing all the mages back to wizards. And so the wizards are now the wizards now be the wizard when they use their spells instead of damage. So and this is also the key issue we need to keep in mind when we're doing automated transformations, and one reason why the WMF wikis are very reluctant to do that. We want to accurately recognize the pattern that we want to replace in the presence of templates and modules and other advanced wikitext techniques. So let's start with Auto Wiki Browser. And I'll just say, in this case, the square bracket example from Semantic MediaWiki is very convenient because currently Parsoid does not parse that, right? So it's a good example of something which you really do have to look at either use Semantic MediaWiki itself to flag it, like I did with the tracking category example, or use some other pattern. In this case, you can't use Parsoid to say, show me the thing which you don't support yet, right? And you could argue that maybe the right way to do this is get Parsoid to reliably recognize it and then replace it. But let's start with Auto Wiki Browser. It's a desktop application, which is really custom built for this sort of task. It does regular expression search and replace. It will let you write your custom code that plugs in to do page transformations. It will even do semi-offline edits with database dumps, so you can find a list of what pages need to be updated offline and do other offline processing before actually making the edits. And it looks like this, which is something. There's a huge amount of functionality there, and it is clearly carefully built to purpose. And it's a good example of the sort of semi-automated technique, which if you maybe feel less certain about letting automated script run rampant on your database, maybe something like this would be more appropriate. PyWikiBot is the oldest bot framework for MediaWiki. It dates to 2003, so only 1 year younger than InterWikiLinks. And it's got a large collection of existing user scripts for various common wiki tasks. So it's probably pretty easy to write new bots. The actual main stuff here is just these 2 lines. And it's worth noting that this TextLib add text, primarily what it does is deal with category links, right? Because you don't want to like add the text at the end after the category links if the category links were out right at the end, because category links should always be at the very end. So it takes out the category links and then adds your text at the end and then puts the category links back in. That's what TextLib does. So like, yeah, invisible links, they're a problem. One disadvantage is that PyWikiBot doesn't have a real wikitext parser, although it has something called MW parser from hell, which despite its name is pretty good, actually. The API is great. But it does rely on a large number of somewhat opaque regular expressions to parse stuff. On the pro side, these are very well tested obscure regular expressions. MWBot is a newer framework, and one of its distinguishing features is that it can use the parsoid parser to actually do something structured with your text. So if you want to, yeah, it's Rust. It is Rust. This is what Rust code for reading a page looks like. You can actually look at like a paragraph tag, and if you want to save the page, it is 1 line. There's also functions that transform from HTML back to wikitext. So if you wanted to do a more structured transformation, you wanted to avoid the wizard problem, right? And be sure that the thing you're changing is actually a link, not just something which happens to share some characters with a link. This is the way to go. There are also automated tools which are extensions native to MediaWiki. So replace text is one. And this one, did I skip a? Yeah, this is just talking about. So replace text is one. It has both a special page. It doesn't have a command line script too, which is a little bit unique. So you don't have to do it via the web interface. It does rely on SQL query support to actually do it, and so it's incompatible if you are storing your revisions in compressed form, because SQL won't go inside the compressed field. So that's a little unfortunate. But this is basically what it looks like. It gives you a special page. You write your regular expression. This is the regular expression to match that semantic MediaWiki property syntax, and then your replacement is #set. And when you do it, it attributes the edit to somebody, probably the admin who did it, and gives a reasonable explanation of what happened. It also works in the command line, like I said, which is kind of nice. I can't say it's more readable, but that's the exact same thing as a command line. And it will let you do a dry run and other things like that. The nice thing about this is it could, for folks who have like a wiki farm or something, this is something that could be plausibly automated. You could do this on your wikis. You just have to get that command right once, and then it's easy from there. Mass edit regex is almost identical to replace text, but the underlying technology is different, and so it's compatible with compressed revisions. And the user interface is very much the same. I'm searching for the square bracket syntax and replacing it with the more modern #set syntax. And it has a nice preview where it shows the changes that it's going to make before it actually makes them. That's very nice. So both these tools are very promising. Here are some thoughts I have about how they could be made better for the content migration task. And this is something I'd really be eager to work with people on Friday about. So first thing is, if a new tracking category or linter rule is added for deprecated syntax, how do we communicate that to you all, right? How do you sort of say, oh, we need to update from where you're at MediaWiki 133, go to 143. Here's the wiki text you should look at, which might be relevant, or at least here are the tracking categories that you might discover are going to show up on your wiki now. We talked before about, hopefully there's not a lot of rich text on your wiki, so probably some of those problematic things won't happen. But I don't think that right now our process for writing release notes is geared towards including information about content migrations to let admins know like what things they should look out for. And then, how can we make the substitutions a little bit more robust to the point where we can actually sort of say, this is a database migration or something that you should feel comfortable running on your wiki, because we are sure that it's never going to do the wizard thing, right? It's only going to replace the actual incorrect markup. And can we get it good enough that we can give you, again, we have a bunch of maintenance scripts that do database updates that we don't use at the foundation, but we still distribute, right? And they are like, for you, when you upgrade your wiki, these are the things that you should run that will update the schema. Can we package a wikitext migration in the same way? And then, maybe there's more of a middle ground between the all manual and completely automatic migrations. Something I'd love to brainstorm about. It seems like there's a big gulf between like, here's a bunch of broken wikitext, find someone to do something about it, and the one where like does magical things to your database behind your back. So that's what I came to present. I'm sure I missed something, and this is the other thing I'd really be interested in talking to folks about. Are there other tools that people are using to do content migrations of various sorts? Like, I don't know anything about how you would migrate a cargo schema or semantic MediaWiki properties, although I poked your brain about that a little bit. And what are tools that we could imagine building that would make this process easier? Because my goal is to make content migration like boring and routine, right? It should be something that if I change, I'll just, parser functions have a weird colon, right? All the rest of the arguments for everything are separated by vertical bars, but after a parser function, it's a colon. Why? What if I change that tomorrow? How would we do that, right? I guess questions, and you've got your hand up, so jump right into that.
Okay. Well, so you were soliciting, what can we do to help? There's a number of times where we've too much depth in our templating, and suddenly it's in a category called maximum templating depth exceeded, right? Mm-hmm. If some of these syntax issues were to be detected by the parser, and it would automatically put them into a category that you could just check and say, oh, my page needs linting category is empty, so my raw text is okay, or these 10 pages have issues.
Right.
Is that straight?
Yeah, no, it is. And the thing, right, the reason I'm here is because that's basically what we've been doing. Like, if you look at these linter categories, like this is, I guess you have to install the linter extension in order to get them. But if you install the linter extension, these start getting populated automatically. But I don't know that we've previously communicated to people like, this is something you could do, and you could actually these actually have reasonable documentation for what actually needs to be done to fix them. Same thing for
so maybe
for the tracking categories, right?
Part of core.
Yeah, that is, again, there's some history why it was separate in the beginning, but that history doesn't matter anymore. So yes, tracking categories are part of core. Like, special tracking categories is on everyone's wiki already. But again, I don't think we communicate very well when a new thing is added there, or which of these you should really care about fixing, versus which of these are just sort of normal, like broken link kind of things. Right? Yeah.
So you were talking about the migration and how to address things that are going to be broken. I've come across various extensions on MediaWiki.org that have a big red banner that says this extension relies on parsing being done in order and will not be compatible with parsoid.
Yeah.
Variable is the example that comes to mind. Can you talk about if you are going to entirely remove the old parser and require parser to be used, is there no plan to support extensions that currently rely on a sequential parser?
It's a good question for 1 minute left. let me try to. Yeah. Oh, look at the time. I can give a short answer. The short answer is, at some point, we expect the legacy parser to be a sort of community-supported extension. If you really need the legacy parser to work, it will probably always be there at some point. But at some point, the foundation itself will probably not maintain it anymore, right? So make of that as you will. The issue about out of order execution of the page is a big performance improvement that will help you all. Trust me. Which is to say, right now, when you've got 1,000 templates, every page of that parts of that page is going to reevaluate from scratch that 1,000 template mess, right? The idea is to reuse the previous version. If nothing changed going into that template, we're just going to take that text from the previous time we rendered it and stick it into your new renderings. But that means that if your extension relies on the fact that it set up some state here, which then is going to use down here, I'm not guaranteeing that we're going to run that part of the thing anymore. We might just be slapping it in from the previous version of the page. So that is a serious issue. There are probably going to be migrations because WMF extensions also have this problem. So we might have a special slow mode for your pages that will still make them work. But the long-term desire is to try to get to the point where we can render parts of the page independently, so that we can be cached independently and composed independently. And you know that sometimes just means you have to do a different data structure thing, right? So instead of numbering everything sequentially, give them a unique hash ID when you come up with them, and then do a final post-processing pass at the end, which hopefully is very fast, that just does the numbering, which is more or less what Site does these days.
There is one question online about, and I'm not sure if anybody in the room knows the answer to this one, but is there a performance difference between the parser function set syntax and the square brackets syntax for setting a property instance?
I saw that in the fab discussion. I don't know, and if I did know, it would probably be different with Parsoid. So, like, there are a couple parts of I don't know there, but it's something we should work with. Like, if that's the only problem, we should fix the performance problem.
Right.